Hello, now we're gonna examine through different kind of move blocks. First we are going to use a move block. For that I'm using a contact and naming it as I0.0. And I'm using a move block right here. And move block is very simple. Whatever be the input is, when the input or the enable is activated, that input file goes to the output. That is the normal move block. So we can use MW0 for the source and MW2 for the destination. So let's see. So you can see we have the source and destination as MW2 and MW0. MW0 and 2. So here I am using the both of the values as 0. Here also 0. I'm making it default. And I'm providing a value for MW0 which is 25. And while I'm trying to turn on the input I0.0, let's see. I0.0 I'm going to turn it on. That 25 is moved to the destination. Simple. That source has been moved to the destination. So that is it. And now we are going to do the next one. That will be the block move. Okay, the block move means it's like a normal move, but it is working like we have a couple of sources. We have numerous sources and also we have numerous destinations. That is a block move. So we are going to the block move BLK MOV. I'm deleting this stuff and making it as a block move. So block move has a source block and the destination block. So source block and a destination block and the return value also. So let me explain what is the block move in the help. If you want to get the help, you can select this block and press F1 in your keyboard. So this is the block move. So you can see we have a couple of sources. If you have a couple of sources, that sources will be moved to the destination blocks in the ascending order. That is a block move. So that should be provided. The source block and the destination block should be provided in the form of pointers. That means that pointer defines how many sources we have, and also that means how many destinations we have. That also in the form of byte, not in the form of word. So let's see. I just want to move 3 sources to 3 different destinations. So I'm using my source is starting from M0.0. Okay, so I'm typing as P hash pointer hash M0.0 space byte space 6. I am using 6 bytes. That means M0.0 it is a byte and it is 6 bytes are combined for 3 words. Okay, one word is equal to 2 bytes. That means 16-bit word is equal to 8 plus 8, 2 bytes. So for 3 words like M0.0, M0.2, like I need to move memory word 0, memory word 2 and memory word 4. For 3 memories that will be moving to M100. So the destination will be same like P hashtag M100.0 space byte space 6. So M100, 102 and 104. So these are the outputs. So the return value will be a distinct memory. So MW50. So that means in the return value, if some kind of errors are happening, you can see on the return value, you will be getting some values. If it is 0, there is no error. 8092, there will come a couple of errors like that. You can see the error log in the help. And I'm not going through that right now. I'm just downloading this. Now this is on the runtime. And I just want to examine these kind of M0.0 and M100.0. So for examining these kind of bytes and words, I am going to show you another thing, that is the watch table. So you can see here watch and force table, and I'm going to add a watch table. So here we just added a watch table 1, and we can add address here. So MW0, from MW0 I am going to add 3 locations, MW0, 2 and 4. And the display format will be in the decimal, that everything, the others also decimal. So the destination is starting from M100, M100 to 3 destinations. Sorry, percentage MW, memory word. Okay, MW100 to 3 destinations, 102, 104. And the data format is decimal. Okay, fine. So let's see the working. And I'm going to the runtime. I just want to monitor this data monitor here. And you can see whatever in the MW0 that is moved to the M100. Whatever in MW2 that moved to the MW102. Whatever it's inside the MW4 that moved to the M104. So let me change the value. Let me modify that value for you. I'm giving 11. And here I am giving 22. And here 33. So 3 values. I just want to modify this value. You can see here you can modify all these values. You will be getting the values as 11, 22 and 33 in the destinations also. So in the PLC, that value should be whatever is inside the value, that will be moved to the destination, and you can see the error log is 0. That is the block move. So we can, if you want 4 blocks to be moved or 4 memory data to be moved from M0, you can give the byte space 8. And here also byte space 8. If you want 4 memory, here I am using 3 destination, 3 sources. So that's why the after byte it is 6. So that is the block move. So I am going offline, and let me introduce you another type of block move or other type of move, that will be the fill move. This is the uninterrupted block move, and I'm not taking right now. I'm just using the fill move. So here the fill move. Here we have a value. That value, if you have a source value, that will be moved to a particular numbers of block. Okay, so that will be moved to a particular numbers of block. If you want to see the help, you can go to the fill move, fill example. Here you can see, here we have the block value, okay, or B value. So we have MW14, 16, 18, 20. 4 memory words we have, that will be moved to the destinations of the block. So let's see. Like the block move, I just want to put a value that will be like in the block move percentage or P hashtag M0.0 space byte space 6. So this is my values, and that will be stores in the destination like P hashtag M100.0 space byte space 6 or 6 or 10. Let's see what happens, and the return value or the error log will be stored in MW50. So let's go and run this thing. Let's see what is the fill move. So I just want to go through the startup. Okay, everything good, and I'm going to the watch table and adding up the watch table elements like MW0. So MW0 to 3 values, that means 3 sources, and the destination starting from MW100, and that also just using a couple of more values. So let's see what happens, and the data format will be decimal for everyone, for the others also. So we can run this thing, You can go for the monitoring. You can see this is my source 10, 20, 30. This is the inside my source that will be stored in MW110, 20, 30. Not stopping again 10, 20. It is storing up to 5 destinations. Okay, it is storing up to 5 destinations. That's why we are using these kind of things like in our PLC program. We can see byte 10. Okay, from byte 6, that means 3 word memories, MW0, MW2, 4, that is storing in MW100, MW102, 104, 106 and 108. That is the 10 destinations. So 3 sources and 5 destinations, not 10 destinations, 5 destinations, like 1, 2, 3, 4, 5. After that, there is no effect. After MW8, that is the fill mode. It's actually filling into specified zones. 10, 20, 30 filled, and again 10, 20 is filling. And if I give 12, that goes to the 30, goes to the MW10 also. That is the filling. Whatever inside the source, that will be filled in the number of destinations that is provided on the block.